So, we've all been blown away by AIs that can chat, that can code, that can create poetry. It's amazing stuff. But what if all that talking is actually a bit of a distraction? Today, we're going to dig into a pretty radical new idea in AI. It's a shift away from models that just predict the next word to models that try to understand the world first, and only then, if they have to, speak.
Right now, the AIs we know and love, the large language models, are basically the world's most sophisticated autocomplete. They've devoured the internet, and they are incredibly good at guessing the most likely word to come next in a sentence. And hey, don't get me wrong, the results are stunning. But there's a catch.
What if getting better at predicting words isn't the real goal at all? This is the question that's driving a whole new approach. Building an AI that first creates an internal model of reality, a genuine understanding, and then just uses language as a tool to tell us what it already knows. You see, it's the difference between faking intelligence really well and maybe, just maybe, actually having it.
The problem with the way we do things now can be summed up with a kind of geeky word, autoregressive. It sounds complicated, but all it means is the AI's entire job is just to predict the next word, and then the next word, and the next. This forces the poor model to get totally bogged down in the details of grammar and synonyms, wasting a ton of energy on how to say something instead of what it actually means.
This slide just lays the problem out perfectly. To you and me, these two sentences mean the exact same thing. But to a word-predicting AI, they are two totally separate, different puzzles to solve. I mean, think about the wasted effort. Instead of just getting the core concept of darkness, the AI has to learn every single possible way you could ever phrase it. It is just wildly inefficient. So how do you fix this? Well, Meta's research lab is trying a totally different angle with something called VL-JEPA. I know, the name is a real mouthful. Vision, Language, Joint Embedding Predictive Architecture. But the idea behind it is beautifully simple. Stop predicting words and start predicting meaning itself. And the secret sauce to this whole thing is a concept called embedding space. The best way to picture it is like a giant map. But instead of cities and countries, it's a map of pure ideas. On this map, the specific words don't matter. The concept of the light turns off and the concept of the room gets darker are in the exact same spot because they mean the same thing. VL-JEPA is basically a navigator for this map of meaning, not a dictionary.
And I love this analogy because it really captures the philosophical shift here. A typical LLM thinks by talking. It spits out words one by one and sort of discovers its own answer along the way. But a non-generative model like VL-JEPA, it figures out the answer first as a location on that idea map and only bothers to translate that meaning into words if we ask it to. It doesn't need to talk to think. Okay, so that's the big picture, but how does it actually pull this off? Well, the whole system is built around this core idea of predicting meaning. Let's just quickly break down the parts. All right, this looks a little scary, I know, but let's just use an analogy. On the far left, you've got the X encoder. Think of this as the system's eyes. It takes in the raw data, like a video clip. That info, plus your question, goes to the predictor. That's the brain. Now here is the magic. The brain's only job is to point to the answer on that meaning map. It doesn't write a single word. It's only if we need an answer in English that the Y decoder, the mouth, kicks in to translate that point of meaning into a sentence. All the thinking happens without any language at all.
Now, this isn't just some cool academic trick. By focusing on meaning instead of words, this whole approach unlocks some seriously huge advantages in efficiency.
These charts show you exactly what I'm talking about. VL-JEPA is the blue line. You can see it learns faster and just plain performs better than the old school model in red. And here's the kicker. It did this with about half the number of moving parts, what they call trainable parameters. In the AI world, that's like building a faster race car with half the engine. It is a massive, massive leap.
Another huge win comes when you're dealing with video. Because VL-JEPA is tracking meaning over time, it can do this clever thing called selective decoding. So it's watching a video, but instead of just constantly narrating, it only generates a description when the meaning of what's happening actually changes. It speaks only when something important happens.
And here's the payoff in a single number. To get the same quality video summary, this selective approach is nearly 3 times more efficient. Why does that matter? Well, for AI to live on our devices, in our glasses, our cars, our robots, it has to be fast and cheap to run. This kind of efficiency is what makes that possible. It's a total game changer.
Now, it's super important to be clear about this. This technology is not designed to be a ChatGPT killer. It's a completely different kind of tool, built for a totally different job. This table lays it all out. VL-JEPA is an absolute rock star at perception tasks. Things like understanding what's happening in a video, classifying an image, finding the right clip. But the traditional generative models, they're still the champs when you need long-form text or complex reasoning that you have to write out. They're just different tools in the toolbox.
And this isn't just a hypothetical. It's already putting up state-of-the-art numbers. On key jobs like video classification, it's already beating well-known models like CLIP. But what's maybe most impressive is on a test for understanding physical cause and effect, it actually set a new record, even outperforming parts of the giant models we all know like GPT-4o and Claude 3.5. So let's just zoom out for a second. What does this shift really mean for the future of AI? In a word, reality. It's about grounding these models in the real world.
Meta's chief AI scientist Yann LeCun puts this perfectly. A 4-year-old child learns about the world by watching it, by interacting with it. The amount of information they absorb through their eyes and ears dwarfs the entire written history of humanity. For AI to get to the next level, it has to learn from the world itself, not just from our descriptions of it.
And that's really the heart of it. This is a move away from text-only intelligence. It's an approach that treats language not as the basis of thinking, but as an optional output. It's a way to communicate an understanding that was formed by directly seeing and perceiving the world. The AI sees first and only speaks when it's necessary. So that leaves us with this really fascinating question to ponder. What happens when the AI in our robots, our cars, and our learning tools has a real, non-verbal understanding of the world around it? I think we're just beginning to imagine the answer.